Let's dive right into the method of charging a fixed orifice air conditioning system using the superheat method. The thing we want to come away with on this is what is the difference between actual superheat and the target or goal superheat. Those are two different numbers. And what we want to accomplish is we want to provide the maximum amount of cooling for this system. We want to make sure we don't damage the compressor or any components with the charge. And we want the most cooling for the lowest energy cost. So we want energy efficiency. So if we start at the condenser, this is the condenser, and what it does is it's providing us 100% liquid refrigerant at a fairly high pressure. Let's just for discussion's sake, let's say that this refrigerant is 200 psi. Well, if you look at your refrigeration temperature charts, as an example, 200 psi refrigerant might have a phase change or evaporation or temperature that it changes, or a boiling point of 100 degrees. This is just an example. So this refrigerant is coming through here, it's liquid, and it hits our fixed orifice expansion device. And what it is just a piece of brass with a small hole drilled in it, and it reduces this from high pressure, this is the high pressure side, to low pressure. So it passes through this orifice and it drops to, say, 70 psi. And if you look on your pressure temperature chart, 70 psi for R22 would have a boiling point or a flash point or an evaporation temperature of about 40 degrees, 40 or 41 degrees. So you can see that we've gone from high pressure, high boiling point, low pressure, low boiling point. So this liquid now travels, it's a liquid that's droplets of liquid and some gas or vapor, and it's going to go to our evaporator coil, and our evaporator coil is blowing, say, 75-degree air over this 40-degree refrigerant in this copper tube that makes up our evaporator coil. And of course, this 40-degree coil is going to suck out the heat from this 75-degree air. So the 75-degree air is going to leave this evaporator, say, at 55 degrees. And our heat is going to be picked up by this refrigerant, and as it picks up this heat, it's going to flash or boil or evaporate, but it's going to stay at 40 degrees until the very last drop of refrigerant has evaporated. So this coil stays at whatever the flash point is, or the saturation temperature, until all of the liquid has boiled off. And when it gets towards the end, when there's no more liquid, then it can start picking up some sensible heat and actually changing sensible temperature. So it's going to start warming up. And what superheat is, it's the amount, the number of degrees above flash point that we've heated this refrigerant to. So our flash point and vaporization temperature is 40 degrees. And if we put our thermometer on the suction line before the compressor, then if we picked up heat and got it to 55 degrees, then that's our superheat. So our superheat would be 55 minus the 40-degree coil temperature, and that would give us 15 degrees of superheat. So we've heated this refrigerant up 15 degrees hotter than the boiling point, evaporating point, phase change temperature, whatever all those words you want to call it. So we have an actual superheat in this system of 15 degrees. So now, is that good or is that bad? Well, we have to have enough refrigerant in this system so we don't damage our compressor, and we have to have that over a very wide range of conditions. And inside the building, we might have return air that's 60 degrees, and we might have return air that's 85 degrees. It might be 20% relative humidity, and it might be 60% relative humidity. So it might have a lot of sensible heat and a lot of latent heat that this coil's picking up, and it can be highly variable. Then on the outside temperature, it could be 60 degrees and it could be 110 degrees. So that's a very wide range of temperatures there too. And our charge has to be account for all of those possible conditions. So we have a mathematical formula, and the formula that we need to determine what our goal superheat or target superheat is, we want to know how much heat is in the air going into the evaporator, and that is sensible heat and latent heat. So we need to take the return air wet bulb going into this coil right before the evaporator, and the wet bulb will tell us how much sensible heat and how much latent heat. Then we need, on the outside, we can just use the sensible dry bulb, because while we're charging this unit or working on this unit, the humidity outside is not going to make any massive changes typically. So just the dry bulb going into this coil is good enough for our formula. So you want to take that in the shade. You want the air that represents the temperature of the air going into that coil to make your formula work right. So you can take the indoor return air wet bulb, the outdoor dry bulb, enter it into a smartphone app. Train, Carrier, York, Linux all have slide calculators where you can calculate, and it will tell you what the target or goal superheat is. You can there are paper charts. You can contact me, and I'll be happy to send you a paper chart that will tell you. Just send me an email or go to the website. And if our paper chart said that we have actual superheat of, say, 10 degrees, and or I'm sorry, not actual. If our charts say we have a goal or target superheat of 10 degrees and our actual superheat is 15 degrees, then we're 5 degrees off, and we don't want to be more than 3 degrees off. So if the actual superheat is higher than the target superheat, you're going to add some refrigerant. If the actual superheat is lower than the target superheat, you're going to take out some refrigerant. So, and we want to try to get within a range of plus or minus 3 degrees of target. So if our target is 10, then we want to be in a range of somewhere between 7 and 13 degrees. And we had 15, so we're going to add a little refrigerant and get it down to 13. 10 ideally, is 10 is what we want to shoot for, but if we can get it 7 to 13, that's fine. And then we want to let this unit run for 15 to 20 minutes to stabilize, recheck it, and make sure our actual superheat and our target superheat are within tolerance, plus or minus 3 degrees of target. So your indoor conditions, especially in the cool times of the year, can change significantly. Your relative humidity and your dry bulb temperature can change. So you want to go back in and recheck your wet bulb, indoor wet bulb, recheck your outdoor dry bulb, rerun your target again and see what it is, and check your gauges for your actual. And that's how you charge a system with the superheat method.